Hello and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at dataengineeringpodcast.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your data pipelines or trying out the tools you hear about on the show. And go to dataengineeringpodcast.com to subscribe to the show, sign up for the newsletter, read the show notes, and get in touch. You can help support the show by checking out the Patreon page, which is linked from the site. To help other people find the show, you can leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host is Tobias Macy, and today I'm interviewing Alex Ratner about Snorkel and dark data. So Alex, could you start by introducing yourself?
Sure, and again, Tobias, thanks for having me on the show. So I'm a fourth-year PhD student at Stanford. I work with Chris Ray and the Dawn project at Stanford, where our goal is to make it to democratize ML. So my particular project that I work on with others in the lab, which we call Snorkel, is about making it easier to generate training data for today's complex machine learning models. So one of the big sea changes that we've seen in the field is the rise of approaches like deep learning, which are very complex models that do a great job empirically of learning how to represent data in a way that leads to very good performance on tasks that are really tough traditionally, like understanding text or images. But the kind of trade-off under the no free lunch policy is that they require much more labeled training data to learn from. So with the Snorkel project, our sort of big high-level technical question is, can we solicit information from domain experts to solve problems like extracting stuff from dark data, which we'll get into, with higher level information that might be noisier from the domain experts, but that's cheaper to provide.
And how did you first get interested in and involved in the area of data management and working with machine learning and the complexities of data management?
Yeah, well, so personally, I had a job after college, actually more in finance, but I was working a lot with the patent corpus, or a little bit at least. I stumbled upon it, and I thought it was incredibly cool that on about a couple terabytes of text data that I could download on a thumb drive or something. You had everything that anyone had thought was worth patentable. But the problem was that it was incredibly accessible, but you couldn't do anything with it. If you wanted to extract an actual usable piece of knowledge, this was something beyond the current limits of the field. Probably in some ways still is, although we're trying to push that boundary. So I kind of looked into how people try to pull useful stuff out of text data or other, as we call it, kind of dark data that's difficult for computers to process traditionally. And this led to the field of machine learning and natural language processing. From there, this is the big question then became, how do you get the training data to teach these machine learning models in a practical way, which led to this project. And then for the lab, more broadly, Chris and others, my advisor Chris and others started working on this DARPA-funded project called Memex, which was primarily focused on pulling in information off of the dark web to help fight human trafficking. And so a predecessor system to Snorkel was kind of one of the big tools used to process that data. And I think that led to a lot of the lab's current interest.
Just as a side note, it's interesting that this came out of Memex because it's the second or third time I've heard mention to that project. And one of them was from a group of people working at Continuum Analytics.
Yeah, Memex was really an exciting project, and I don't know whether this is an aside or an answer, but there were, the work that Chris led, which started before I joined the lab, but then I helped out with a bit, was one piece of the pipeline. It was there were parts upstream of us where they pulled in the data from the dark web, and then our job was to take a mess of text data and turn it into something that looks more like a spreadsheet that then could be used by downstream components to visualize and make predictions and all that sort of stuff. So it's a really cool tech stack that was started by that DARPA program.
Definitely. And so you briefly touched on the idea of dark data and gave a cursory definition of what it is, but I'm wondering if you can just do a bit more defining of what the dark data problem actually is and how Snorkel actually helps to alleviate some of the issues that are associated with dealing with that type of data source.
Great. Yeah, so dark data is also known as just unstructured data, and that's a nice term to make a simple distinction. A lot of the data that we use is structured, so you could think of a database or an Excel spreadsheet or a graph, sort of all equivalent, but something that has a known schema. And this is the kind of data that's really easy to for modern computers technologies to leverage, whether you want to visualize it or make predictions based on it. We have a lot of, a very extensive tech stack built on top of taking in, nicely structured data. But if you actually look by volume, most of the data in the world is unstructured. So this includes text data, all the sort of semi-structured data stored as HTML on the web, images, video, time series, all this kind of stuff that is traditionally easy for humans to process slowly. And hypothetically, if a machine could process it, it could do it much more broadly and at scale, but it's very tough for a machine to do. So generally, machine learning is the technique that actually gets us access to, or does best currently at getting access to dark data. So for example, if we have a bunch of text documents in the scientific literature and we want to pull out specific facts about certain chemical interactions, today the best solution would be to use a machine learning model, in particular a deep learning model, to do this information extraction. However, the problem is that this kind of machine learning, for all the strides it's made lately, requires a ton of hand-labeled, what we call training data. So training data is just a bunch of labeled examples that were labeled with sort of the ground truth answer that a machine learning model learns from. So for example, if you're doing that chemical extraction, you'd have a human, scientist say, go over all of these documents and highlight where two chemicals were mentioned as interacting, or whatever other thing you're trying to pull out. And then you train the model to be able to do similar extractions. So this is obviously a very expensive process. And as the models that people use have gotten more and more complex, the amount of labeled training data that's needed has grown exponentially. So the idea with Snorkel is that instead of asking for thousands and thousands of nicely labeled examples, we try to get higher level but noisier inputs, like rules or patterns or noisy data sources, and see if we can use this to train these machine learning models. And it turns out that actually in a lot of instances we can. And so instead of having months go into hand labeling a data set to train a model, you can have a domain expert sit down and in hours or days write a bunch of labeling functions and get the same performance.
And as you mentioned, one of the main requirements for Snorkel to be able to operate on these data sets is to build a labeling function that takes advantage of that domain knowledge. So I'm wondering if you can talk about some of the more challenging aspects of being able to build those types of functions in such a way that they can be verifiably accurate and effective for producing usable outcomes, and if there are any sorts of tools or techniques to assist in that verification process.
Yeah, that's a great question. And in some ways, that's the whole name of the game. I mean, it's been a long-standing goal in the field of AI to make it easier for domain experts to inject their knowledge into a system. And so the goal in Snorkel is kind of to make it very easy to inject this knowledge and then use it to train a machine learning model and thus leverage all the power in those techniques. So one of the sort of the main technical component of Snorkel has to do with automatically estimating the accuracy of a bunch of labeling functions without ground truth data. So intuitively, if you provide a set of labeling functions, say a couple dozen of them, Snorkel applies them to a large amount of unlabeled data, ideally, and then looks at where the labeling functions agree and disagree. And based on that, and with some other very loose statistical conditions, it can estimate the accuracies of the labeling functions and then weight them accordingly. So this isn't perfect, obviously. Writing a labeling function involves sort of encoding domain expertise into a rule or a pattern or something similar. Concretely, a labeling function is just a Python function. So it still takes time to write them, and this is an iterative process. But then Snorkel automatically models the noisiness of them and outputs a denoised set of labels, which can then be used to train some end machine learning model.
And when I was reading through the documentation, it looked like the primary interface for working with Snorkel was via the Jupyter Notebook. And I'm wondering what the sort of typical workflow looks like for somebody who wants to take advantage of Snorkel and build those labeling functions and run them through a data set.
Yeah, that's a great question. And we have a bunch of tutorials online where there are examples of labeling functions. But suppose you were approaching this the chemical interaction extraction task I mentioned, which is actually a good proxy for a current project that we're working on with some researchers at the Food and Drug Administration and some other researchers at Stanford. So what you do to start is we have everything is built or there's a lot of tooling built for this Jupyter Notebook interface, which we find is a good one, especially for our collaborators who are using Snorkel. So you might start by looking at a small set of data that you might label it just to get a sense of the data. And then the goal would be to write a set of these labeling functions, which are just Python functions that take in a data point and say yes, no, or abstain, for example. So for this chemical extraction task, you might write a simple labeling function that just looks at a pair of words. And if it sees, or suppose that we have all of the chemicals already annotated using an upstream tool. You might write a labeling function that takes in a pair of two chemical mentions in a document and just looks to see if the word causes appears in between them. And if the word causes doesn't appear, it just abstains. And if the word causes appears, it says, yes, this is a valid chemical interaction mention. And maybe if not causes appears, then it says, no, this is not a chemical interaction. So this is just a couple lines in Python, and that's really all there is to it. And then what the user would do is that they would write a couple of these labeling functions, and then they'd run Snorkel on it. And Snorkel would learn to weight the labeling functions based on its estimate of how accurate they all were, and then would use these outputs, the denoised outputs, to train an end machine learning model that would learn to generalize beyond the rules that you wrote down as labeling functions. And then, of course, it's an iterative process in that you can always tweak the labeling functions and develop them further. And Snorkel's estimates of how accurate the labeling functions are give some feedback on which ones you might work on. One other interesting advantage of this kind of an approach to training a machine learning model that I'll mention, because it comes up a lot with our collaborators, is the fact that you are not locked into a particular extraction schema. So with a lot of, in general, if you're doing a supervised learning problem, you need to decide ahead of time how to specify the problem. And then say, having made that decision, you decide, well, these things are valid chemical interactions and these things are not. I'm going to discount them. Say you then went through a traditional machine learning route that people do a lot in practice, where you then go and pay some scientists to spend a couple of months labeling training data. And then actually you get the extracted stuff and you realize that actually your problem specification wasn't quite right. You actually don't want to have chemical reaction type A because it's not useful for whatever you're using this data for. And you do want to include chemical reaction type B, which you excluded. The only answer in a traditional machine learning pipeline would be to throw out your training data and start all over again, which is a hugely expensive and impractical proposition. So the idea with Snorkel is you could just go back to your labeling functions and just tweak them until you've corrected the specification. So this allows much more flexible iteration on actually using a machine learning model in practice.
And I can imagine that being able to provide these labeling functions, particularly for industries where it's difficult to collect large volumes of data, or the data that you are collecting is difficult to work with in some of the traditional machine learning contexts, such as if it's large raster files like you might have in meteorology or satellite imagery that you're using in a sort of agricultural context. I'm wondering if Snorkel would be useful for data engineers and data scientists to be able to then take that source data and make use of it within a machine learning context where it might otherwise be difficult or impossible to gain valuable insights from it.
Yeah, that's a great question. So at a high level, the ingredients that are needed to actually use Snorkel are you need ideally a large amount of unlabeled data. So say you are trying to classify some satellite images, you need a bunch of, you need ideally a large quantity of those images, even if they're not all labeled. And then you need some kind of way of writing the labeling functions. So for text, as I was kind of giving some examples of, you might write some regular expression patterns. You might use some external databases that you found online of chemical interactions that may or may not be reliable. You just throw them into Snorkel. For images, one of my lab mates is currently doing a lot of cool work on if you have some features of the image that are pulled out by other algorithms, you can write labeling functions over those features and provide supervision that way. Another interesting route that we've been taking with some of our collaborators in the radiology department at Stanford, which has actually worked quite well, is if you have some metadata that you can write labeling functions over, this can work really well too. So for example, in one of our recent projects, we had a bunch of chest X-ray images and we wanted to classify them. Specifically, we wanted to train a machine learning model to classify them as, say, benign or malignant. And then we also had a bunch of the unstructured text reports that the radiologists had dictated. And so writing labeling functions over the image was kind of hard, but we could very easily write a couple dozen labeling functions over the text reports, looking for certain phrases and patterns and stuff like that. And all of the labeling functions were noisy, meaning none of them were higher in accuracy than, say, 70 or 80%. But by feeding them into Snorkel, we could use this to generate much higher quality training data that we then used to train a machine learning model that did only a few points worse than a similar machine learning model that had been trained with 100,000 labeled data points that had been collected over a period of several years. So it hopefully offers a workflow that is much faster and more practical and more efficient. That is a much more practical and efficient way of using machine learning than the standard one of label a massive training set and then apply the model.
And I imagine that because of the fact that you can more rapidly generate labeling, whether it's as accurate as you might get from some of these larger data sets or not, and being able to then get usable models from a smaller data sample, that it would also allow a lot more different types of organizations or companies to actually leverage machine learning capabilities, because they can obtain data sources in a much more affordable fashion than is typically required for some of the machine learning contexts that are largely only accessible by larger tech companies or larger institutions.
Yeah, that's a great point, and it really is the foundation of our motivation here. Going back to the as mentioned, the Dawn lab at Stanford, the goal is sort of democratizing ML. And as far as Snorkel goes, assembling training data by hand is a hugely slow and expensive proposition. Even if you don't factor in what I was talking about before of getting locked into a particular schema or problem specification, just doing one set of training data annotation is a hugely impractical thing. So if you look at, if you look at, the data sets that machine learning of late has made some of its most impressive gains on, they took years to assemble. So for example, there's a data set called a labeled training data set called ImageNet. And this has been one of the sort of big success cases of modern deep learning. So this, recognizing cats versus dogs versus hot dogs and hundreds of other image categories. But again, this took years to plan and assemble and annotate this labeled data set. And it didn't even require experts, it didn't require doctors or anyone with domain expertise to label. So now, if you're talking about a problem that requires, trained radiologists, say, to label, this is an even more expensive and massive proposition. So again, the hope with Snorkel is that by taking in training signal at a higher level and in a noisier form, and still being able to use it to train high-quality machine learning models, we can make it much easier for smaller organizations or for research labs or for individuals to use state-of-the-art machine learning.
And how is Snorkel built and architected in order to be able to take advantage of those noisier data sets and produce usable outcomes? And how has that design evolved over the course of its lifetime?
Yeah, so there's, the core architecture of Snorkel. There's there's a database that manages all the sort of bits of input and the labels that get attached to them. And we've done a lot of work on trying to make it usable with the Jupyter notebooks and even some of the pre-processing tools for text and other stuff. And then on the machine learning and the algorithm side, Snorkel basically has two stages. So there's a what's called a generative model, which learns, as I mentioned before, to estimate how accurate the labeling functions are. So if you put in 30 labeling functions, and some of them are really precise and accurate, and some of them are barely better than random, and in general, we assume that they're non-adversarial, so we assume that they're better than random, then Snorkel can learn without labeled data just by looking at how they agree and disagree with each other to come up with a model of their accuracies. And then it can weight them accordingly, weight their labels accordingly. And then the second stage is just any standard machine learning model that you plug in. And the difference now is that this end machine learning model is being trained with probabilistic labels output by Snorkel, rather than yes, no, say, yes, no, or multi-category labels as it would be standard. And I guess as this has evolved, we've tried to identify certain aspects of this kind of new paradigm for training machine learning models that could be automated or improved to make it easier for the user. So one example, a recent success, is my lab mate, Stephen Bach, led a project on trying to learn the structure of correlations between labeling functions. So you could imagine intuitively that if you wrote two labeling functions that were exact duplicates of each other, this could cause problems. So imagine you had two copies of the same labeling function, but Snorkel didn't know that. Then you'd get a double counting problem. Because they would always agree with each other, Snorkel would think that they were more accurate than they might be. Or say, as has actually happened, you have a couple different engineers writing labeling functions, and they end up writing labeling functions that overlap heavily and are kind of expressing the same pattern or the same data source. This again can cause issues with Snorkel's estimation of the accuracies of those labeling functions. So we added a module to Snorkel based on a cool bit of machine learning work that actually automatically learns to detect correlations and account for them in Snorkel's model. So we've been doing those kinds of additions. That's been a lot of our work on the research side. That then it's sort of a call response. We throw Snorkel out into the open source. We work with collaborators. We see what causes them the most headaches, and then we see if we can come up with a solution on the research side and ideally port that back into Snorkel.
And have you seen a lot of adoption in industry for Snorkel and the type of problem domain that it's trying to address?
Yeah, so we've had a lot of great industry collaborators who have come by. We have a weekly office hours, so we have a lot of interaction with some companies that are up on the Snorkel website at snorkel.stanford.edu, but including Accenture and Toshiba, Alibaba, a bunch of others, and so that interest has been very exciting, and we've gotten to see at a high level, how they use Snorkel and how it went for them. And then a lot of our interaction that we've been sort of fully hands-on with has been with academic collaborators at Stanford. So a lot of people in the biomedical informatics space, working with people at Stanford Hospital and at the VA here. So yeah, it's been really exciting, and we've learned a lot from those collaborations.
And what are some of the situations where Snorkel would be a poor fit for the problem case that somebody might be investigating it or evaluating it for?
Yeah, it's a great question. So I guess there are kind of three obvious answers, and then there are plenty of more nuanced technical ones, I guess. But so first of all, the motivation for Snorkel is for training really complex models. So for example, deep learning models have, which are the exciting and most empirically popular set of machine learning models today for a lot of use cases, like in particular text and images. They have up to hundreds of millions of trainable parameters. So they're hugely complex on any metric of complexity. And therefore, they sort of need a commensurate amount of labeled training data. Now, hypothetically, if you had a really simple model, like you had logistic regression over 20 features, you wouldn't need that much labeled training data. And therefore, you might just want to label it by hand. You might not want to go down the Snorkel route at all. So that's one that's one bit of where Snorkel is intended to be useful. Another thing is that Snorkel learns how to weight the accuracies of the labeling functions using no labeled data, but it needs a lot of unlabeled data to apply the labeling functions to. So it's Snorkel is mainly motivated by situations which from our experience are very common, where you have where it's easy and cheap to get access to unlabeled data. It's just difficult and expensive to label it for your particular classification task. And then finally, using Snorkel requires you to write these labeling functions. It requires you to have some kind of noisy signal. So again, this noisy signal could be labels from crowd workers. This case is nicely subsumed by our system. It could be patterns over text. It could be other databases or knowledge bases that you have found somewhere that might be really noisy or inaccurate for your task, but provide some signal. But there needs to be something there. So the biomedical domain is a great example of this, because the National Library of Medicine, for example, has built all these ontologies and data resources. And for a given task that we approach that we might approach, you want to pull out this type of chemical interaction from the scientific literature. Chances are there's not going to be any perfect fit with any of those data sets. But using Snorkel, you can kind of use them all to give signal to train the model, if that makes sense.
Yeah, those are great answers. And what are some of the most interesting applications of Snorkel that you're aware of or have been involved in?
Well, there's multiple dimensions of interestingness. I think in terms of the novelty, at least from where I sit side, we're doing some work with this project in part at Stanford called the Empirical Studies of Conflict, and so we have it's actually run by a guy named Joe Felter, who's now a Assistant Secretary of Defense at the Pentagon, but he did his PhD studying conflict in studying insurgency conflict in the Philippines. And so we have this very unique data set of combat reports, and we're trying to use Snorkel to pull out specific attributes that then international policy and conflict researchers can use to study. And that's a standard template where we have messy data set, and we have a bunch of collaborators who have all these exciting research questions that they want to answer, which could even involve downstream machine learning problems, but they need the data in a usable format. And so if we can just do that, which we often can with Snorkel, then they're off to the races doing all kinds of exciting stuff. Another cool instance is I guess that radiology project I mentioned, where we can take those text reports and actually use them to provide training signal that is nearly as good, several just mere points away in terms of end performance from these massive labeled data sets that hundreds of thousands or even more dollars were spent to annotate. So that's really exciting to us in terms of, again, democratizing machine learning and making it easier and cheaper to apply.
And when I was reading through the documentation for Snorkel and some of the other information that you have available on your website for it, I was noticing that it appears you have built some additional tools that either use Snorkel as part of their functionality or feed into or feed off of Snorkel. So I'm wondering if you can just talk a bit about some of the other work that you're doing where Snorkel has been of benefit within your group.
Yeah, that's a great question. So I'll do some shameless advertising for my lab mates. There's a number of cool projects that are sort of either built on top of Snorkel or are sort of built proximate to Snorkel. And a lot of them, we have blog posts up at snorkel.stanford.edu, sort of dumped a lot of the lab's material into that page. So, for example, I can name a couple. So there's a project called Fondeur that my lab mate Sen works on, which is built on top of Snorkel, and it's aimed at handling what they call richly formatted data. So this is, if you could think of text or even images as just purely unstructured data, and you could think of, say, an Excel spreadsheet where you know what the columns are as a nice format of structured data that is really easy to use. That's sort of the end goal with a lot of our Snorkel deployments. There's a lot of data that falls into a middle category where there's some structure, but it's got all these different variances and you don't really know what the structure is ahead of time. So examples of this include HTML, where there's clearly structure, but it's just, there's a long tail of all different types of formats. It includes PDF documents that have some structure, but it's, there are 1,000,001 ways to have any given form or document, and stuff like that. So Fondeur is aimed at that. There's a really cool project my lab mate Paroma works on called Coral, which is trying to extend writing labeling functions to images, which I mentioned before. So it's a lot harder to write labeling functions over images than it is for text. But if you have some features that were extracted using some upstream algorithms, like say you have bounding boxes around objects, say you want to write you want to train a machine learning model to detect whether there's an image of someone riding a bike, and you have bounding boxes around people and bikes, you could then write a labeling function over that saying, if person is vertically positioned above bike, then say yes. And this adds some unique complexities to the problem that Coral takes care of. There's a project called Babel Label, which is by my lab mate Braden, which is asking whether you could actually, instead of writing labeling functions as little snippets of Python code, could you just describe them using natural language and then actually parse that into a bunch of labeling functions? And it's very cool. Clearly, it works surprisingly well. And I think that the trick is that labeling functions themselves, the way that we expect them to come into Snorkel, we expect them to be noisy. So this produces a larger set of even noisier labeling functions that get parsed out from the natural language that you speak or that you type in. But we can still actually do surprisingly well with this. And then finally, we have done some work on another trick that people use a lot in practice heuristically to make up for lack of labeled training data called data augmentation. And we view this as another way of having domain experts inject their knowledge. So, you might augment your training set by making copies of the images, say, but rotating them all slightly or blurring them all slightly. And because you know that rotations or blurs shouldn't really change anything for your end classification problem. So we have some software for automating that process as well. That can be used in concert with Snorkel to generate even more training data.
And in your experience, what have been some of the most challenging aspects of building and working with Snorkel and the problem sets that are associated with it?
There are some domain-specific problems. All the unstructured data is very messy to deal with. And there's a high bar to assembling the upstream tooling before you can even get to the point where you apply the core technical bits of Snorkel or where you apply a machine learning model. You have to, say you want to do that chemical extraction I mentioned. You need to do all the parsing and pre-processing and stuff before you even get to the point where you can write a labeling function looking for the word causes. So that was one thing that was certainly an interesting aspect. And then, a lot of the things that have been challenges they're now, either completed or ongoing research projects. So I mentioned that problem that we noticed of having correlated labeling functions and how that messed up the model in Snorkel. And so we at least have a pretty decent solution to that now. And ditto with problems of how do you write labeling functions over images, or how do you write labeling functions if you don't know how to code, stuff like that.
Are there any particular features or improvements that you have planned for future releases of Snorkel?
Well, there are a number of sort of things on the software engineering side that I'm a little hesitant to say on record, because then my advisor is going to take a lot of joy in brandishing it. But for example, yeah, he most certainly will. Both myself and my advisor Chris are very excited about a specific deep learning framework called PyTorch these days. So right now, Snorkel works with TensorFlow, and we want to also extend it to PyTorch. There's a lot of engineering stuff like that is on the docket. Also, I mentioned there are two modeling stages of Snorkel. One where the generative model, where it learns the accuracy of the labeling functions, and then there's the discriminative model that is just that makes the end predictions that you're interested in. And there's a way to train them jointly that would greatly simplify the architecture that we want to put in. And then one other interesting thing that I'm working on now is extending Snorkel to better handle the setting of what's called multitask learning, which is an exciting area that a lot of people in machine learning are exploring these days. And I guess the intuition behind it is that even though it might seem that training more models at the same time would just be harder, if these models actually share information about how they're learning to represent the world, it can actually be easier, and you can actually do better training a machine learning model to do multiple things at the same time, rather than just training it to do one narrow thing. So we're very interested in exploring this in the context of weak supervision and the kind of inputs that Snorkel uses.
Are there any other topics or areas of discussion that we didn't discuss yet, which you think we should cover before we close out the show?
I think that's a good covering of topics. I guess I can add in that that from our perspective, we coined the cheesy phrase that training data is if data is the new oil, labeled training data is the new oil. And again, if you go out and talk with people trying to use machine learning models, especially the newest and fanciest, say, deep learning models, as we've done with a lot of our collaborators when we were developing Snorkel, especially in the last couple of years, you don't see a lot of people who are concerned about some particular property of the algorithm, or even in the last 5 years or so are struggling to engineer features for their model. Really, the bottleneck that you run into is that it's tough to get training data. It's expensive, it requires a lot of time, and it locks you into a particular problem specification or schema, as I'd mentioned. So that's really our highest level motivation for Snorkel, is to make it easier to overcome this bottleneck when you don't have the resources to pay an entire building of people to label your training data for you.
All right. Well, for anybody who wants to follow the work that you're up to, or get in touch and ask any sort of follow-up questions, or get involved in the work you're doing, I'll have you add your preferred contact information to the show notes.
Oh, I was just going to pitch that Snorkel is all open source. It's on GitHub, and we love getting issues. We actually like getting complaints more than we like getting positive feedback, because it gives us stuff to work on and improve. So definitely feel free to check that out.
And as a final parting question to give people something else to think about, I'm wondering if you can share your perspective on what the biggest gap is in the available tooling or technology for data management today.
Yeah, that's a great question. I'm very biased, obviously, but I think that machine learning is really quickly becoming an essential tool in the toolkit of a lot of people in data management, whether it's for doing dark data extraction from text or images, like I mentioned, or even whether it's using machine learning to do or to optimize, say, traditional data management stacks. And so I think there's a lot of exciting work, and we hope that Snorkel falls into that category of exciting work. But I think there's a lot more to come in terms of systems specifically for machine learning. And so this is everything from how you get training data for your models, like we're trying to do with Snorkel, to how you efficiently serve the models and actually run them, say even on the edge on smaller devices, how you debug them, how you make them more interpretable, how you in general program them like you would any other part of your data management tool stack. So I think that's going to be at a really high level one of the most exciting areas, this intersection of machine learning and systems development that coming up in the next couple of years.
Well, I appreciate you taking the time out of your day to join me today and talk about the work you're doing with Snorkel and weak supervision and dark data extraction. It's definitely a fascinating area of research and one that I'm happy to see progress being made. So I appreciate you taking the time, and I hope you enjoy the rest of your day.
Thanks so much for having me on the show. It was a pleasure to chat.